Hi there. Today we're going to discuss misleading graphs and statistics. What will we learn today? Today we're going to identify a misleading graph, and then we're going to explain how statistics might be misleading. Here's our first example that I want you to consider. We have Stanley Cup playoff leaders, Gretzky, Messier, and Curry. So when you're looking at this graph, according to the size of the players, how many more points does Messier have than Curry? So if you're looking at it, um, we're looking at how much bigger this figure is than this figure is. Well, just by looking at size, it looks like it's about 2 times as many. So the reason why we think it's 2 times as many is because this figure is 2 times as big as this figure. Now, do you think this is a representative of the player's points? And explain. So if you're looking at this, Messier has about 290 points, and Curry has about 230 points. According to size, it should be twice the amount. But if you're looking at it, 290 is not double the points of 230. It's only a difference about 60 points. So the graph is a little bit misleading. And another thing I want you to think about is what reason could someone have for intentionally creating a misleading Stanley Cup graph? The reason why they might want to do that is because they want the total points for like Wayne Gretzky to seem bigger than it already is, or Messier bigger than it already is. All right, so this is what we call a misleading graph, when the data that is pictured does not actually represent the number data. Identify a misleading graph. Graphs can let readers analyze data easily, but sometimes they're made to influence conclusions by misinterpreting the data. So reasons why graphs can be misleading is the intervals are not consistent or the same. So if you're comparing more than one set of data, the actual intervals on the y-axis might not be the same, and like small intervals will show bigger change than the big intervals, and you'll see some examples. Here's our first graph, graph A and graph B, and they discuss spring dance tickets. So you're taking a look at the data and they don't look the same. You know, if you're looking at the data, you can see that like graph B has bigger changes than graph A. So you might be like, oh, just by the looks of it, graph B has bigger changes, they have bigger increase. But if you look at the data itself, you'll find out that they're the same. Like in 06, it's 4, 07 is 4, um, 08's about 5, 09 is about 6, and 10 is about 8. And the same thing happens for graph B. So the reason we might be looking for is, why does this look different than this graph over here? So the graphs show the same data, however, the graphs differ in that graph A, this interval goes by 4 and this interval goes by 2. So the smaller interval showed a bigger change. So graph B makes it appear that the prices increase more rapidly, even though the price increases are the same. And they're also asking, which graphs might the student council use to show that ticket prices have risen? Uh, the increase is not significant, and why? So if you're thinking about which graph you should use, okay, if you want to show that the change has increased, if they want to say, oh my God, if someone's saying, look at the prices for the spring dance, they increased so much, you would use graph B, okay? Just to be like, this shows a big increase. But if you're kind of like on the student council side where you're like, no, the changes haven't made much of a difference, you would use graph A. So this is why we talk about misleading graphs, is that you can choose a graph that will tell people what you want them to know. Okay? All right. So let's show this graph right here. The line graph shows the sales for Crumbie Cookie Bakery. Which graph makes it appear that the sales declined only slightly? Is this a valid conclusion? And explain. So what you're looking at here is you want to choose a graph that shows little change. And remember, I said that if you want little change, you're going to want to choose the one that has a smaller interval. So here our intervals are by like 200. I'm sorry. If you want to show a little change, you have to choose the big intervals. So here, these are intervals about 200, so they would show a smaller change than this one, which goes about at 75. So if you wanted to show a slight decline, you would choose graph A. The intervals are not the same on both graphs. Graph A appears to show a slight decline, while graph B shows a sharp decline, which means the bigger changes, bigger lines. Okay? All right. Here's Got It A. It's in your book on page 814. The line graphs show monthly profits of a company from October to March. Which graph suggests that the business is extremely profitable? Is this a valid conclusion? And then explain. Well, if you're looking at the graphs, you want to see something that's extremely profitable. And that just basically means that they're making a lot of money. Um, so although both graphs are showing a profit, which is just the increase, in graph A, the increase in profits is exaggerated, meaning it looks a lot bigger due to the intervals of both 500 and 100. So here are intervals here. I'm sorry, I thought, yeah. Uh, the interval here goes by 500s, and so does the intervals over here. But if you'll notice, this goes by 500, 500, and then all of a sudden it changes by 100s. Okay, so now once the interval changes, and you really shouldn't have inconsistence on one graph, but once it changes and makes a smaller interval of the 100, the increase looks so much bigger. Okay, so this is a little misleading. Um, but again, some people do this so that they can have people see what they want them to see. Misleading statistics. Statistics can be used to influence conclusions. So these are basically the mean, the median, and the modes. Sometimes people use these statistics to tell people what they want them to know. They may not be the best representation of the data. So here's example number 2. An amusement park boosts the average height of their roller coasters to 170 feet. Explain why this might be misleading. Okay, so if you're taking a look at this, okay, you're looking at the data. It's 109, 135, 115, 365, and 126. And they're saying like, hey, we have this height of our roller coaster. It's an average of 170. But you're looking at all of them and you're like, most of them are not even anywhere near 170. So where are they getting this from? So you're going to take a look at the 3 different statistics, the mean, the median, and the mode. Okay, the mean is basically, the average. So we added up all these numbers divided by 5, and that's how they got the 170. The median, we put the numbers in order, and the number in the middle was 126, and there was no mode. So we had to choose between the mean and the median. So the average used by the park was the mean. This measure is much greater than most of the heights listed because of the coaster that's 365. So the reason why the mean ended up so high was because of this one tornado roller coaster that was 365. So it's misleading to use this measure to track the visitors. The more appropriate measure to describe the data is the median, which is 126 feet, which is closer to the height of the other coasters. Okay, so if you wanted to find a good representation of the data, that would be the median. Here's another example. Michael and Melissa both claim to be earning a C average, 70 to 79%, in their Latin class. One student is wrong. Which one? Explain how he or she used a misleading statistic. So here, Michael's mean is 53.4, Melissa's 71.9, and their medians are both 70. So I think when you're looking at this question, they say average, and average means the mean. So Michael's mean is a 53.4%, which is not a good average, by the way. Okay, so the reason why he thinks he's earning a C average is because his median score or his middle score is a 70. So Michael's wrong. He claims to be earning a C because of his median of his test grades, which was 70, but his mean or average is much less than 70%. So Michael is wrong. Okay, here's an example. Got it B. It's on page 815. Find the mean, median, and mode of the sofa prices shown in the table. Which measurement might be misleading in describing the average cost of a sofa? Explain. Okay, so I'm not actually going to go over what the mean, the median, mode is because you can figure that out yourself. Um, Median and mode. Okay, so your mean, we're going to add up all of these numbers, 1700, 1400, 350, 1650, and 1400, divide them by 5. That equals 1290. When you put these all in order, the middle number is 1400, and your mode is 1400. So the mean would be the misleading graph. Okay, and this is because the value of the mean is lower than most of the setup data. So you wouldn't want to show your mean. Like if you were just kind of like the company and you were like, oh, check out our sofa prices. Our mean is so low, or our average price is so low. That would be misleading for the customer because they're expecting to pay about 1,290, but you can see there's so many numbers. Actually, there's one, two, three, four. 4 out of 5 of the numbers is higher than this mean. So if you're walking in there and you're like, I'm expecting to pay about 1,290, and you only see like only one out of the options is under that. So that's why it would be a little misleading. All right, so I hope that video was helpful. Thank you. Bye.